you know, given your background at NASA, this took 9 years to happen. Why? Tell us about the technology that made this happen.
Yeah, so Pluto is really far away. And, you know, to have a spacecraft that can last in deep space for 9 years is really hard. It's very, very cold out there, and the spacecraft needed heaters to survive and needed to travel a really long distance to make the trip. So that's how long it takes to travel to Pluto.
So, Michael, just how historic is this? How difficult was this to pull off?
An extraordinarily difficult mission and a beautiful mission. Tremendous perseverance on the part of NASA, Alan Stern, the PI, and all the hundreds of people involved in it, putting this great technology together. We've really wanted to go take a look at what's going on out there, the outer part of the solar system. Never had a clue. Now suddenly we're getting this magnificent image back, and I'm sure thousands more in the coming 24, 36 hours.
So, Chris, how do they design spacecraft that can withstand these kinds of conditions?
Yeah, it's a really tough engineering problem. And so space is very, very cold. When you get our spacecraft, the Planet Labs are in orbit around the Earth, so the Earth keeps us warm. We're about room temperature. That is not true in deep space. You're basically at 0 degrees Kelvin, so very, very cold. So New Horizons, the spacecraft going to Pluto, carries a radioisotope thermal generator that generates power and heat to keep the spacecraft alive. And you're so far from the sun, you can't use solar power for getting energy. So the spacecraft basically has a radioisotope generator for temperature and power.
Now, Michael, we're already learning some new things about Pluto and deep space, but what are the most significant things you would say that we've learned so far today? And what could we learn still?
Well, we can see that there's geology and that there's a lot going on the planet, and there's weather going on at the same time. It's not the same kind of icy, watery clouds, but there's clearly methane, ammonia, nitrogen, substances that we don't normally think of as being responsible for weathering processes. There's craters, a lot of them on the surface of Pluto. We can see them pretty clearly. And there are also geological features that either could be valleys or canyons. Maybe there's some subsurface stuff going on that's carving these features out. It's clear that as we get closer in and resolution gets much, much better, even than this fabulous picture we've already seen, there's going to be a lot more clues to try and unravel the history of Pluto. We do now know for the first time that it is the biggest object out there. There was a toss-up between it and Eris, one other Pluto-like twin. Pluto seems to have won that contest, just by a few miles, but it's the biggest one out there.
That is crazy to me that we didn't know how big Pluto was until today. Now we know exactly how big Pluto is. But Chris, you know, what else can we learn here? Because can't we learn some stuff about how Earth evolved?
Yeah,
right?
That's absolutely true. So interestingly, Pluto was discovered in the mid-20th century, and its orbital period, the time it takes to go around the Sun, is 248 years. So since we've discovered it, it hasn't not orbited the Earth once yet. And so we didn't actually know how large it was or how far away it was. So for navigating to Pluto, that was really hard because we didn't know if it was big and close or small and far away.
Right.
So that was a huge challenge. This will tell us a lot about the formation of the solar system, how the planets are formed, what else is out there. It's really interesting.
And there's also, Michael, a huge polar ice cap on Pluto. What are the implications of that? I know that life on Pluto is highly remote, the remote possibility of that.
Well, I prefer never to say never until we actually get a probe out to Pluto, land on Pluto, and drill deep underneath Pluto's surface. I don't think we're going to know absolutely for sure. I think it's very unlikely. But the fact that there is both geology, that there are polar caps, that these polar caps melt or rather sublime, that stuff goes up into the atmosphere, clouds or some other processes we don't understand well move the frozen liquids, the nitrogen, the methane, the ammonia, from one side to the other of the planet are all extraordinarily interesting. The only sad thing about New Horizons is that it can't hang around. We just didn't have the energy to send along thrusters to slow it down and put it into orbit around Pluto. That would have been awesome. But we're going to collect more data. New Horizons has already collected it and will soon send it back in the space of just a day than we've learned in the 85 years since Pluto was discovered.
And Chris, one last quick question, but what kind of other missions does this make possible, public or private, or public and private?
Yeah, so I think people weren't sure if Pluto was interesting at all.
Yeah.
And it hasn't got a lot of attention. This mission was very hard to fund, and I know that Alan Stern and the other investigators tried tirelessly for decades to get this funded. Now that they've gone there, they've been proven right. That this place is fascinating, it is more complex than we ever imagined, and that there is a lot of stuff out in the distant solar system that is worth exploring. So I hope to see a whole bunch of private and public missions going out and exploring more deep space.